why do they have to keep it cold? Because mirrors flex as they heat up and cool down. So they want to keep it the same temperature as the night air, so that the mirror doesn't flex, and they don't have to wait for the mirror to cool down again.
This upside down means distress.
Distress. We're going to have to evacuate, I know.
You see, this is what I get, because you see, I matched it up on this side, but I was putting it on.
It doesn't matter when the inside.
I don't know what he's doing. Okay. Let's get started.
There's still two coming.
There's still two coming? Okay. Scopes, and they've got exhibits, and they do lectures, and they do star parties and things like that. Griffith Observatory is an observatory, but it was built for public outreach and education. And the contrast I want to draw is between Griffith and this institution. Griffith does public education. This one does research. Now, I'm going to try to convince you in the course of this tour that this is a really, really neat place. And one of the reasons it's so neat is because this observatory was designed 80 years ago by people using slide rules, right? And, well, what do we do with iPods and CD players and things like that that are 80 years old? We throw them out, right? This is still an active research institution. We do research 300 nights a year. Even though it was designed 80 years ago and went into service 65 years ago, roughly 1949. There's a 6-month waiting list. People who want time on this telescope to do academic research into a whole series of questions in astronomy. Tonight they are looking at high energy sources called Fermi blazars, which are really bright quasars, which are really bright objects of various kinds. And they'll be doing that research tonight. I'd like you, this is the best place to get a look at the dome, to get a sense of how the observatory is constructed. The dome is 137 feet high, 135 feet across. The dome weighs 1,000 tons. On the other side there are two shutters that open to make an aperture. The dome turns to keep that opening above the telescope as the telescope tracks objects during the night. The dome was designed by Russell Porter in Art Deco style. It was meant to look like, well, it was meant to look like something other than a barn. I mean, a lot of the other telescopes look like a barn, like barns. It was meant to look like the kind of the archetypical telescope observatory. There are 4 reasons why this observatory remains a primary research institution. It's because the mounting is a nearly perfect machine, and they need a perfect machine to precisely track the stars as they appear to move from east to west during the night. You know, they take long exposures here, and they've got to be able to track objects very precisely. Second reason is the optics are almost perfect. We'll talk about how the mirror was made. The third reason is that there are other telescopes on the mountain that work with the 200-inch telescope. so that all of these telescopes do more than any one of the telescopes can do alone. And having said there were 4 reasons, I've forgotten the 4th, but I will try to remember it. This is the first tour, so we're kind of getting into it. What I'd like to do is draw your attention to this strange piece of concrete here, and I would like to ask, what is it?
I know.
Yes?
Excuse me? I'm sorry, I couldn't hear. The solar system.
Nice idea. I'm sorry, that's not what it is. It is 200 inches across. It weighs about 20 tons, if that's a hint. It's not much of a hint, is it? No. It is not the mirror. It's not exactly what transported the mirror, but we're getting closer.
A counterweight of some sort?
Very good. Right on. Yes, absolutely. Thank you. We've had lots of interesting answers over the years when we asked that question. One of my favorite is one person thought it was the tomb of the unknown astronomer. It is not. But in fact, you are right. It functioned as a stunt double for the 200-inch mirror. In the 1930s, they built the observatory and the mounting. The mirror wasn't done until didn't get here until 1947. They needed something to put in the structure of the telescope to test the tracking mechanisms that are so critical to how the telescope operates. So they poured this piece of concrete. It weighs just about what the completed mirror weighs, and they put it in the back of the telescope to test out all of the tracking mechanisms. Before the mirror got here, they took it out, somehow brought it across here, and of course dumped it the first place they could because it weighs so much, and it has remained here. Of course, would ruin long exposures when they're taking pictures. Now, we're going to go upstairs and we're going to see that 530 tons of mounting and telescope and this big structure. We came in through this tiny door over here. Everything we're going to see upstairs, the telescope and the mirror, and you'll notice above us there are panels on the ceiling. Those panels lift off. Way at the top of the dome, 137 feet above us, there is a 50-ton crane in the dome, and everything was lifted up and assembled on the floor above us. In 1937, they brought the mirror. I think probably most of you came up S6, that was known as the Highway to the Stars. It was built by San Diego County specifically for the observatory. November 1947, they brought the mirror up the Highway to the Stars, brought the truck in here, and the mirror was raised up by that crane, brought to the dome, and on the floor, the final figuring of the mirror was done. Now, one of the things I pointed out that's important to this being a current research institution is the fact that this is such a perfect machine. This tracking, this pointing, is better than most of the bigger telescopes out in Hawaii and the Canary Islands. As evidence of that, let me draw your attention over here to these big wheels over on the wall. When they were building this, starting in the mid-1930s, they were building, yes, a machine, and machines wear out. And they figured the critical parts of this machine are the gears that drive the telescope north-south and east-west. And in 1936, he could not go to Home Depot, to the spare big gears aisle at Home Depot, and get had spare gears when you needed them. So what they did was put together, cast 2 spare gears for when the gears in the telescope wore out and had to be replaced. Well, okay, I suggest to you that they have come to the conclusion that within some reasonable amount of time, the telescope, the gears that are in there are never going to wear out because the telescope is so perfectly machined and perfectly balanced. How do we know this? Because they built this laboratory. This is the optical, the AO lab, the adaptive optics lab. They built this lab in front of those gears, and they would have to tear that lab out in order to get to the gears to put them in the telescope. They are basically never going to be. The telescope is that good. The adaptive optics lab, one of the reasons, in fact, that was the third reason, come to think of, or the fourth reason, come to think of. One of the reasons this telescope is still in use after so many years is we've upgraded parts of the optical system. And we have what is probably the best adaptive optic system in the world working on this telescope right now. It's a system that looks at motions caused by movement in the atmosphere that distorts an image, and using computer-controlled deformable mirrors corrects for that turbulence, and we can get images that are as good, as better, or better than those of the Hubble telescope and those of the larger telescopes out in Hawaii. Mirrors. These telescopes are mirror telescopes. They're reflectors. They don't use lenses. And the mirrors use a coating of aluminum to reflect light. And that coating has to be renewed periodically. And this white chamber over here is used to recoat the mirrors, all of the mirrors of all the telescopes on the mountain periodically. They do it periodically every 2 years or so. They do all of them except the 200-inch in this chamber here. We'll see a larger version of this on the floor above, where they do the 200-inch